In this video, we're going to solve a word problem involving antiderivatives and motion. It says a particle moves in a straight line and has an acceleration given by a of t equals 3t minus 1 meters per second squared. Its initial velocity is v of 0 equals negative 2, and its initial displacement is s of 0 equals 5 meters. Find its position function s of t. If you remember from previous sections, s of t is the position function, and s prime, or the derivative of s of d, is equal to the velocity function, and s double prime of t is equal to the acceleration function. They give us the acceleration function, so they want us to go backwards basically from the acceleration function and figure out what was the original position function. To do that, we're going to have to take antiderivatives. We'll have to do it twice. So we'll start with, I'll call this s double prime of t is equal to 3t minus 1. So s prime of t is going to be the antiderivative of this, which would be 3t 1 plus 1 over 1 plus 1 minus 1. We don't have a t here, so we'll say t to the 0 plus 1 over 0 plus 1 plus c. So we get s prime of t is equal to, that'd be 3 over 2 t squared minus 1t plus c. And they tell us that the velocity, which is s prime, of 0 is negative 2. So we can find that c by plugging in 0, negative 2. So we're going to do that over here. We're going to say negative 2 goes in for s prime of t is equal to 3 over 2 times 0 squared minus 1 times 0 plus c. So you end up with negative 2 for c. So s prime of t is equal to 3 over 2 t squared minus 1t minus 2. So s of t, when I take the antiderivative of this function, I get 3 over 2 t to the 2 plus 1 over 2 plus 1 minus 1 t to the 1 plus 1 over 1 plus 1 minus 2 t to the 0 plus 1 over 0 plus 1 plus c. And then I'm going to evaluate that, so I get s of t is equal to 3 halves divided by 3 would just be 3 over 6 t to the third power minus 1 half here, 1 over 2, because of the 1 plus 1 there, t squared, minus 2 over 1, so that's just minus 2t plus c. So then what we want to do is we want to find we want to use this information, s of 0 equals 5 meters, to find the c value. So we're going to say that 5 is equal to, and I'm going to reduce 3 over 6 to say 1 half. 0 goes in for t, minus 1 half 0 squared, minus 2 times 0 plus c. So we end up with c is equal to 5. So we can write that equation then as s of t is equal to 1 half t cubed minus 1 half t squared minus 2t plus c, or not plus t, c, plus 5. Should be a 5 there. And that is our position function, our original position function.